for today that says show graphically the region where the inequalities 3x plus 4y less or equal to 12, 2y minus 3x less than 6, and y greater than 0 are simultaneously true. Now, for this kind of question, the first thing you have to do to be getting the solution of this kind of question is to first write these inequalities in such a way that y becomes the dependent variable. You write these inequalities in such a way that y becomes the dependent variable. In other words, we need to determine the boundary lines. To determine the boundary lines for these inequalities, the boundary line for this, the boundary line for this inequality will be simply you have 4y, 4y, you have 4y equals 12 minus 3x. If you want to take it further, this will imply that y equals 12 minus 3x over 4. Then the boundary line for this inequality here, you need to find the boundary lines because it is very important for our solution. The boundary line here will be 2y equals 6 plus 3x. And taking this further, your y will be equal to 6 plus 3x over 2. Then here, the boundary line for this last, which is y greater than 0, will simply be y equals 0. That will just be the boundary line for this. Now, for us to determine the region of where the set of solution to this linear inequality lies, the next thing is to find the intercept of x and y. How do we find the intercept of x and y? To determine the intercept of x and y, we'll find the value of, using the boundary lines, we are going to determine the value of x equals the value of x, 12 minus 3x. Let us find the value of y where s is equal to 0. Now, where s is equal to 0, this will be 4y equals 12 minus 3 times 0. So it implies that 4y, 3 times 0 here is 0, will be equal to what? 12, which shows that y here is equal to 12 over 4, and that is 3. It means that the ordered pair here for x and y, remember x is 0 here, we have 0, comma, and y is 3 here. Okay? When we say ordered pair, we are talking about the ordered pair of x, comma, y. Now, again, we will look for the value of x using this boundary line when y is equal to 0. Remember, we have that the boundary line here is y equals 12 minus 3x. Y is 0 here, so this will imply 4 times 0 equals 12 minus 3x. Of course, this will give us 0. So we have here that this will imply that 0 equals 12 minus 3x. If I move 3x from this right hand side to the left hand side, I will have that 3x is equal to 12. Now this implies that x will be 12 over 3, and that's simply 4. The other pair here will be our x here, the value of x is 4, and the value of y here is 0. So these 2 points, we use these 2 points to plot this boundary line, 4y equals 12 minus 3x. Moving on, equals 6 plus 3x. We find the intercept of x and y. Here, we'll find the value of y when x is equal to 0. Okay? So here we are going to have that 2y equals 6 plus 3 times 0, and that will imply that 2y, of course, 3 times 0 here is 0. 2y is equal to 6, and that further means that y here is equal to 6 over 2, and that is 3. So the ordered pair here, x comma y, which is the coordinate, will be x is 0 and y is 3 here. That's the ordered pair there. Then we come again to find the value of x when y is 0. So here, using our boundary line here, 6 plus 3x, y is 0 here. So this will mean 2 times 0 equals 6 plus 3x. 2 times 0 is 0. Further, this will be 0 equals 6 plus 3x. And of course, to get s, I move this here, I'll have that 3s equals minus 6, which implies that x equals minus 6 over 3, and that gives us minus 2. So here we have that x is minus 2 and y is 0. So I've got x here to minus 2, comma 0. So our points that we use to plot for this boundary line will be 0, 3, minus 2, 0. All right. Then finally, for the last inequality, y greater than 0, the boundary line for this will be y equals 0. So right away, we'll find a line where that satisfies, the region for this inequality. To do that, I'll quickly draw the Cartesian graph. Of course, your Cartesian graph is made up of your x and your y-axis. Here you have your y-axis. Okay, this is your positive y-axis. Here you have your positive x-axis. This is just a rough sketch, a rough graph. Ideally, you're supposed to have it on your graph note. This is your origin, 0, 0. Okay. Now, to the positive side of x, you have this to the, let's say this is 1. If I graduate this is 2, this is 3, this is 4. I'll stop there for that, and so on, of course. You have other numbers, proceeding from that. Here you have minus 1, minus 2, minus 3, minus 4, and so on, numbers going there. Here you have a positive values of y, 1, 2, 3, 4. And coming down here, you have minus 1, minus 2, minus 3, and minus 4, and so on. These values continue. Now let's go ahead using the points we have to plot the graph. For the first boundary line, which is this, the point we are having for this boundary line, we have 0, 3, 4, 0. We use this point to plot the boundary line. Now, here is a very important thing we need to note. For this boundary line, we can see coming from the inequality that gave rise to the boundary line, this inequality here, the inequality sign here says 3x plus 4y is less or equal to 12. What it is telling us is that if we are to determine the region, because we have it as less or equal to, it means that the line itself is part of the solution. The line itself is part of the solution. And because the line itself is part of the solution, I will draw the line with bold line. But for this case where we have a strict inequality, the line is not part of the solution. So the line will be joined with dotted lines. I will use dotted lines to indicate that the line is not part of the solution. So let's go ahead to plot the boundary line for this inequality. The values we have are this point and this point. So first, we have 0, 3. That is, along x is 0 and y is 3. S will be 0 along the y-axis here. S is 0 along this line. And the value of y here is 3. So this is the point. Okay? Then x is 4 and y is 0. Y is 0 along the x-axis. And x is just 4 here. Like I said, the inequality there says 3x plus 4y is less or equal to 12, which means the boundary line is part of this solution. So I will join with my free hand. Please note that we're supposed to, you should do this on your graph note. But for the sake of this, I will use my free hand to just show the thick line here. Thick line here. Okay, this is just to help us explain the fact that the boundary line is part of the solution. But then, where is the region? In this line, which region is the solution and which is not the solution? We go back to what we have. This boundary line is 3x plus 4y equals 12. But the inequality that we are considering here says 3x plus 4y is less or equal to 12. Less or equal to 12 will be, since it is less or equal to 12, this is the inequality. 3x plus 4y is less or equal to 12. Whereas this is the boundary line. Now, to put this into consideration, I have decided to make this line to be bold. The region that is less or equal to minus 12 are down this way, down the line. They are below the boundary line here. While the region greater than or equal to 12, 3x plus 4 greater than or equal to 12 are above the line here. The region not required are here, so I will shade the region not required. Or rather, I will use these lines to indicate the region not required. So what I have simply done here is to use these lines to indicate that this region is not required. In other words, our solution lies from here down to this point. This is where our solution lies. So here, what you have is 3x plus 4y greater than or equal to 12. But here we have 3x, below this line we have 3x plus 4y less or equal to 12. This is the required region. Coming to the second inequality, which is 2y minus 3x less than 6. The second inequality is 2y minus 3x less than 6. And the boundary line for this is 2y equals 6 plus 3x. And at the end of it all, this was our ordered pair, which is the ordered coordinate that we use in plotting this. But again, I said we need to take note of the strict inequality here. This strict inequality simply means that the line is not part of the solution set. So if I plot this, I will not use bold line. I'll use dotted lines to mean that the line is not part of the solution. These are the ordered pair that I will use in plotting this point. Or these are the points that I will use. So first, our x is 0 here, and our y is 3. Where do we have 3 along the y-axis? You can see that this is the y-axis. Along this y-axis, x Along the y-axis, x is 0. X is 0 along the y-axis. So here, y is 3 and x is 3, still at this point. We still have it to meet at this point. Okay? And then we have x to be minus 2 and y is 0. Along the x-axis, y is 0. So, and x is what? Minus 2 here. Please, I didn't mark 2 here. I have to mark minus 2 here. It means that because the line is not part of the solution set, I'm going to use these broken lines, or what you can call dotted lines. For some people, they will use dot, but let me just use these broken lines. I use broken lines to indicate that this line is not part of the solution set. All right? Going to the inequality, you see that the solution here, the strict inequality tells us that the required region is below this boundary line because it's less than. The region not required, they are above this line here. So this one is where you have 2y minus 3x greater than 6, whereas what we need here, this is the boundary line here, it is simply 2y minus 3x equals 6. But above here we have 2y minus 3x greater than 6. They are all here. But what we need here actually is 2y minus 3x less than 6. So this is around this region. Then we come to the last inequality here, which says y is greater than 0. This is the y-axis. The values of y greater than 0 are, look at them here. 0 is not included because it's not greater than or equal to 0. Greater than the values of y greater than 0, look at them. Greater than 0 are 1, 2, they are up going this way. Okay? Which is actually the region that we require. So the values of y less than 0 will come down this way. In short, the line, that value is supposed to, it will be broken lines. Just because I use this as my x-axis, it should be a broken line to indicate that this is the region not required. Because in this region that is shaded, if this is the boundary line y equals 0, in this region that is shaded, we have y less than 0. These are the values. Then the values of y greater than 0 are the values up here. Now, looking at this triangle is a clear indication. The solution lies in this triangle you are seeing. The solution lies in this triangle, this point down to this point, down to this point. So all values that lie within this point are the solution set for the combined inequality 3x plus 4y less or equal to 12, 2y minus 3x less than 6, and y greater than 0. These three, from what we have in this graph, are simultaneously true. And this gives us the solution to the question we have been asked to look into. So this is how you can determine the solution to combine a linear inequality in two variables. So in two variables, you can determine that graphically. And that is what we just showed from this point, that this region is the solution. I will see you. Don't forget to subscribe. I'll see you in the next class. Don't forget to subscribe to my YouTube page. Please drop a comment in any area of maths that you need answer, solutions to. You can drop a question in the comment section. And also click on the notification bell so you can always get notifications each time I post a new video on this channel. Thank you so much.